العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. We will continue talking about conditional probability, inshallah, in this lecture. So remember that probability of E1 given E2 is probability of E1 intersection E2 over probability of E2. We solved one exercise and let us continue and solve another exercise from the book. Suppose a quality manager for Dell computers has collected the following data on the quality status of disk drives by supplier. She inspected a total of 700 disk drives. So there are total of 700 disk drives and we have this table. Now if you look to this table, you will find two variables, drive status, this is one of the variables, and we have two status, either working or defective, and there is also another variable which is the supplier, and as you can see we have four suppliers. Okay, so we have two variables and these data are between these two variables. So for example, if you look to 180, if I ask you what does 180 represent, so you will say that 180 disk drives came from company B and they are working. Okay, so we have 180 working disk drives from company B. If I ask you what about 20, what is this 20? You will say, oh, there are 20 defective disks or drives came from company D. Okay, so these are the numbers. What are the questions about this table? First question, based on this inspection data, what is the probability of randomly selecting a disk, yani one disk drive from company B? So if you select a disk drive, what is the probability that this disk drive came from company B? So in fact, he is asking if we call company B B, so he is asking about probability of B. To find probability of B, as usual, we need to find how many disks came from company B. Okay, this is company B. We have 180 working plus 15 not working. So the total is 195. So 195 came from company B, and the total number of disks, as mentioned in the question, is 700. So probability of B would be 195 number of disks came from company B over the total number of disk drives, which is 700. So this is probability of B. Another question, what is the probability of a defective disk drive being received by the computer company? And he didn't mention any company, he said in general company. So he is asking about defective disk drives. If we call this event D, capital D, so what is the probability of the disk being defective? Yani selecting a disk from these 700 disks, what is the probability that this disk is defective? Well, the total number of disks is 700, and we would like to know how many defective disks are there in the 700 in the total. So these are the defective disks from all the companies. If you add all of them, 20, 30, 20, 50, so the total number is 50. So there are 50 defective disks. So the probability of a defective disk being selected is 50 over 700. That's the probability. Another question, what is the probability of a defect given that? Well, given that means conditional. Conditional. So for a conditional probability, we have a vertical bar like this, and we put the condition here. What is the condition? It is after given that company B supplied the disk drive. So we know that this is the given information. We know that company B supplied the disk drive. So this is something known, happened. Company B supplied the disk drive. Now, what is the probability that this disk drive, which supplied by company B, is defective? So what is the probability of D given B? You can find this probability, as we mentioned before, in two different ways. I can use the definition of the conditional probability, which says that it's probability of D intersection B over probability of B. It's okay. And we can find that easily. D intersection B, defective intersection company B, defective, defective, company B. This number is the intersection between company B and defective. So we have 15 probability of defective, probability of the intersection would be 15 number in the intersection, 15 disks in the intersection over the total number of disks. Probability of B, as we just found in part A, okay, 195 over 700. If you divide 700 cancels with 700 and your answer would be 15 over 195. Now, if you try to find this probability in another way, you can do that. He said, given that company B supplied the disk drive, so you can only think of company B and you can forget about all other companies because you know that the disk has been supplied by company B. So just concentrate on company B. So how many disks came from company B in total? 195. So you divide by 195. And what do you want to know? How many defectives? What is the probability that it is defective? So you divide 15 by 195. You will get the same answer. So in fact, you can immediately write 15 over 195. This is accepted because it is also the probability of D given B. Let us let us solve another one. Yani. More, one more example from my side. Okay, it's not here. What if he asks probability, okay, of B given D? Okay, now this is D given B. Will it be equal to B given D? The answer is no. How to find this? Now I will find it from the table without the formula because it's easier and quicker if you understand. What is the condition here? D. What does it mean? I know that the disk is defective. So the information given here is the disk is defective. So how many defective disks in total? 50. So I divide here by 50, the total number of defective disks. And what is the probability that it came from company B, given that it is defective? Okay, now I go. Where is company B? I have 15 came from company B, so 15 over 50. So probability of B given D would be 15 over 50, while probability of D given B would be 15 over 195. So I hope that it is clear. Another example of the cars on a used car lot. 70% have air conditioning, AC. 40% have a CD player, CD. So there is a car uh, lot, and there are cars in that car lot. And we know that 70% of these cars have air conditioning. So if we say that this is the set of all air conditioning, if we draw a Venn diagram, 70% have air conditioning. So I can write, for example, probability of AC, I call air conditioning AC. What is the probability of AC? If we select one car from all of the cars in the car lot, what is the probability that this car has air conditioning? Your answer should be zero point 0.7 because he said 70% have air conditioning. So the probability of AC, a car having AC, is zero point 0.7. Okay, what about CD player? Probability of CD player, probability that the car has a CD player is 40% because 40% of cars in the car lot have CD players. Okay, good. 20% of the cars in the car lot have both. Both means there is an intersection between AC and CD. what is in the intersection? So he gave you also this information that AC intersection CD is point 2. So in the intersection, I have point 2. In the intersection, I have point 2. What is the probability of AC? AC in general, point 7. Okay, point 2 are here. So what is remaining here is point 7 minus point 2, which is point 5. What about CD? In general, I have point 4. Point 2 is in the intersection and point 2 outside of the intersection. So what is the meaning of this point 5? Point 5, 50% of the cars have air conditioning, but not CD player, have air conditioning only. 20% of the cars have CD only, CD player only. 20% have both air conditioning and CD player. If you add these numbers, you will get zero point 0.9. Okay. What about the total number of cars of percent? It could be 100. This is 90%. Still 10%. What about these 10%? Yeah, these 10%, zero point 0.1 of the cars, 10% of the cars have neither air conditioning nor CD player. Nothing, nor air condition, neither air conditioning nor CD player. So you understand the experiment. This is all the information. Now let him ask what he wants. You can answer any question if you understand the problem like this. So the question says, what is the probability that a car has a CD player given that, okay, so what is the probability that a car has a CD player given that means conditional, given that what it has AC. So I know that it has an AC. I know that the car has an air conditioning, but what would be the probability if it has an air conditioning that it would have also uh, a CD player? So this is a given a conditional probability, and I can use the formula. It says probability of CD intersection AC over probability of AC. That's the definition. So the intersection is zero point 0.2 and the intersection, the probability of AC is zero point 0.7. So the answer is 2 over 7. Uh, what is the probability that a car has a CD player or an air conditioning? Or means he is asking for CD, or you can write it as union, or you can just write it or. It's okay. So CD union AC, using the first definition in the previous objective, probability of CD plus probability of AC minus probability of the intersection. These are this is the rule. So what is the probability of CD? Uh, I have here zero point 0.4, okay, and probability of AC zero point 0.7 minus probability of the intersection, which is zero point 0.2. So the answer is zero point 0.9, which is actually came from here. You know that the probability of the union is zero point 0.9 because this is the union. You add zero point 0.5 plus zero point 0.2 plus zero point 0.2, you get zero point 0.9. What if he asks you, what is the probability that a car has neither ACD nor air conditioning? Okay, let us write this question. What is the probability that a car has neither CD nor AC conditioning? Okay, so neither nor, this means 1 minus zero point 0.9, which is zero point 0.1. Okay, so this means in fact neither nor, this means يعني CD union AC complement. Okay, complement. It's the complements. It's not having CD, also not having AC. فهذا probability is 0.1. Okay, another question. A company has 500 employees. Of these 500, 300 hold college degree. Let me call college degree just D. capital D. Suppose two employees are to be randomly selected. So we will select two employees. Please pay attention to this exercise. Are to be randomly selected to receive a front row parking space. What is the probability that the second person, okay, the second person selected has a college degree, given that, so it's a conditional probability, the first person selected also has a college degree. Okay. I can understand, I can solve this question in different ways actually, but I'd like to solve it using a tree diagram. And please pay attention to the tree diagram, okay? It will help you understanding the problem. So this is the first employee. I will select an employee from the 500 employees. The question, we are going to select two employees. So let us talk first about the first one. Select the first employee. What are the possibilities? Well, he either has a college degree, let us say D1, so the first employee has a college degree, or not. Not means the first employee has no college degree. So these are the possibilities. So if the experiment is selecting one employee of the 500, this would be the sample space, either college degree or not. If I ask you, what is the probability of D1? Can you find the probability of D1? Yes. How many has college degrees? 300. So you simply divide 300 by the total number of employees. So 300 over 500, this would be the probability that the first employee has a college degree. What is the probability that the first employee has no college degree? The complements the other 200 employees without no college degrees. So this is everything is clear up to here. If we select one employee, these are the probabilities and this is the sample space. Now we need to select another employee, second employee. Okay, second. So if you select another employee, there are some possibilities. What about the first employee? If the first employee has a college degree, you see this if the first employee has college, this means given, this means conditional probability. So all the choices here in the second branch of the tree are in fact conditional probability because you are assuming that D1 has happened. Okay. If D1 happened, the second employee could have also a college degree. Let us call it D2 or N2. And here, if the first employee has no college degree, the second employee also could have a college degree or no college degree. And the sample space would be four different possibilities: D1, D2, D1, N2, N1, D2, N1, N2. We will have four uh, outcomes in the sample space. Four outcomes. So this is the sample space. And we have four outcomes: D1, D2, D1, N2, N1, sorry, N1, D2. So the first one has no college degree, while the second one has, and the first one has no college degree, and also the second one has no college degree. So these are the four possibilities in the sample space. Okay. Uh, what is this probability? What is the probability of D2 given D1? Okay. Now the number of employees is not 500 because we have selected one of them. So we have still 499. So always we divide here by 499. Always 499 because we have selected one of the employees. Okay. What is the probability of the second employee has a college degree? If the first has a college degree, this means we have selected one of the 300. So we still have 299 with college degrees. And here also we have 299 with college degrees and 200 without college degrees. because we have selected one of the college degrees employees. While here we have selected one of the 200. So the number of employee receiving college degrees would be as it is 300, but here we will have 199. So what is the question here? Probability that the second person has a college degree, so this is D2, given that the first person, D1, also has a college degree. So he is asking about this probability. And this probability is just this number, which is 299 over 499. So all of these four probabilities are conditional probabilities. If I ask you, what is the 200? Of course, this is the question, خلاص. But I may write here, I need to solve or to write some more questions, more probabilities. Let me say more probabilities, not in the question. This is I'm doing for sake of illustration. Okay, this is the answer. The answer to the question up to here. That's the answer. Now more probabilities. What if I ask you to find probability of N2 given D1? What is the probability of N2 given D1? Your answer should be 200 over 499. What is the probability of D2 given N1? Your answer should be 300 over 499. What is the probability of N2, the second employee has no college degree, given that the first has no college degree? 199 over 499. So these are the other conditional probabilities in the question. All right. What if I want to find probability of D1, D2? What if I ask you to find probability of D1, D2? What is the meaning? What is this probability? This is the probability that the first employee has a college degree and the second employee also has a college degree. So this is and. How do you find and intersection? If you remember, if you use this formula, if you multiply cross multiplication, the probability of the intersection would be probability of this times this. So I can write probability of D1 given or intersection D2. I can write it as probability of D1 times probability of D2 given D1. Probability of D1 is 300 over 500. Probability of D2 given D1 is 299 over 499. So this would give you probability of D1, D2. Please, at home, try to find probability D1 into, probability N1, D2, N1 into similarly. So D1, N2, for example, would be 200 over 499 times 300 over 500 times, always multiplication. Each one of these probabilities would be multiplication because it is and. And if you add the probability of these four outcomes, it should be 1 because it is the sample space. So please check this at home because it's very nice and interesting. Last thing I want to add, I can also find probability of D2. Okay. What if the question, what is the probability that the second customer, the second employee has a college degree? Regardless the first, I'm not talking about the first. I need only the probability that the second employee has a college degree. The probability that the first one has a college degree, 300 over 500. But what is the probability that the second one has a college degree? Well, here you have two possibilities. The second one could have a college degree and the first one also have, and the second one could have a college degree, but the first one it doesn't have. Okay, so you have to mention both cases. So you multiply 2 يعني in fact you say probability of D2 given the intersection D1, either the first one has also a college degree, or probability of D2 and N1. So the first employee could have a college degree or not. So this is or union. These two are mutually exclusive because either the first employee has a college degree or not. So the probability of their union would be the sum. Okay, you just add them. And we have seen here that the probability of D1 intersection D2 is this one. So the answer would be 300 over 500 times 299 over 499 plus D2 in 1, which is 300 over 499 times 200 over 500. I know that this may be a lot about this question, but please review it again and again until you understand it, because this is the main question in this section actually. How to, from the tree diagram, how to ask about probabilities. So we can ask here about three different probabilities. Pay attention. The conditional probabilities, these are the conditional probabilities. The intersection, we multiply, or the probability of one of these. And here we need to add, multiply and add. Okay. Let me end this lecture by talking about conditional probability for independent events. Two events are independent if the occurrence of E2 does not influence the probability of E1. So we have probability of E1. We know the probability of E1. Now, given E2, what would be the probability of E1? If they are equal, this means that E2 has nothing to do with E1, does not influence E1, because we have the same. The probability is equal. Okay, so this is the definition of independence. If probability of E1 given E2 equals probability of E1, this means that the two events are independent. And if the two events are independent, this must be true. Okay, of course, this or this, both are correct, because you can talk about probability of E2 given E1, and this would be equal to E2, which means E1 does not influence E2. So this is the definition of independence. Let us answer one question. This is an example. We have gender variable here, male, female, and time. We have 1, 2, 3, 4, 5 different length of time with the company. The question, determine whether the time, this variable, the time employee is with the company, is independent of the gender. So is the time independent of the gender? Independent. Asking about independence, I need to satisfy this definition. So how to prove that time is independent of gender or not? I take one of the parts here, one of the types, gender, male, female, choose one of them. I'll take females, for example, okay, and call it F, and choose one of these here, time, different for 5 periods. Let me choose this one, for example, 10 to 20, and let me call it Y. So if I prove that Y and F are independent, then time and gender are independent. How can I prove that F and Y are independent? I have to use this definition. So, for example, probability of F given Y should be equal to probability of F. Or probability of Y given F should be equal to probability of Y. If you prove that this is true or this is true, then they would be independent. Okay? If this happens, then Y and F are independent. So gender and time would be independent, but we need to prove this. So let us find out each one of these. What is, I will prove this one, the first one. What is probability of female? Okay, to find probability of female, I need the total number of employees total number is 200. Okay, the number of females, how many females in total? I have 150. So 150 over 200, this is the probability of females. If you divide, the answer is 3 over 4. Good. So this is the probability of F. Now, what is the probability of F given Y? You can use the formula, or you can use from the table directly. I will find it here from the table directly, so please pay attention. There is a condition. The condition is Y. So this is the condition. It has spent from 10 to 20 years. So the total number of employees spent from 10 to 20 years are 48. So I'm going to divide by 48. And probability of F, so I'm looking for the females here. The females here are 36. So the probability of F given Y would be 36 over 48. If you divide, you will find it 3 over 4. Oh, so probability of F is actually equal to probability of F given Y. This immediately proves that F and Y are independent, hence time and gender are independent. This would be the last thing today. Tomorrow, next time, inshallah, I will give more examples about independent events.